Okay, so to change this from a regular function into this, which is its inverse, there was a three-step process. What was the very first step? It's simple. Change it to y. Good. What's the next step? Flip x and y. Everybody do that and then solve for y. Do it. You learn math by doing it, not just by watching it. So you subtracted 4 first, right? Then what'd you do? Times by 3. And I do that on this whole side, like that. And this times 3 and this divide 3 cancel, and x is alone. Is that what I wanted? Oh, I didn't reverse x and y yet, dang. Okay, that's why I was messing with my head. Okay, sorry about that. I should have reversed x and y. Now I'm getting the y alone. Okay, now y, I just multiplied by 3, and then y is now alone. Y equals 3x minus 12. Raise your hand if you had that one right. Okay, good. So that is a inverse. That is the simplest kind of inverse. Then there was domain and range. This guy's domain and range is what I want to find. And once I find it, I'm going to reverse it to give the inverse's domain and range. So let's just say for a minute, this one's really boring because it's all reals and all reals. But let's say that it had been from 2 to infinity and from, negative 3 to 5 or something more interesting. Okay, let's say it had been that. Then this guy's inverse would be domain, range. All I have to do is reverse them. The domain becomes the range. And the 2 comma infinity goes here. And the domain comes from the range. So there we go. It's negative 3 comma 5. You see how they just reversed? That's all you do to get domain and range, is find the domain and range of the original one and then flip-flop them. All right. The harder kind were like this. I'd like you to see if you can plow through the 3-step process. I already did the first step of that. I replaced the y. Replace the f of x with the y. You just flip-flop x and y and then solve for y. See if you can hang with that algebra. Multiplying by y plus 3 on both sides. Hopefully you knew to do that. That cancels that. Yx plus 3x equals y. Now here's a good sticking point. A lot of people don't know what to do right here. And you got to keep asking yourself, you're trying to get what alone? Why? I already had x alone in this green equation back up here. X was already alone if I wanted that. I want y to be alone. So I got to get the y's all together first. First we cluster them up. So I'm going to move the y over here, and I get yx minus y plus 3x equals 0. All I did was move the y to the other side. Now it's over here and it's negative. Okay. Next thing is I'm going to get the 3x to the other side. Yx minus y is equal to negative 3x. Notice when I moved it over here, it became the opposite. Now, I got the y's all in the same spot, and here's the big moment where either you have this skill or you don't. You got to be able to factor. Factor out the y. Notice there was a y in both of them. That's why I could factor the y out to the front. If I multiplied this back out, it would give me yx minus y, and that's what I had. Okay, now why did I do that? Because now I've only got one y instead of 2. Now I can truly get the one y all by itself. Dividing by x minus 1. Y is now alone, and that's the answer. Negative 3x over x minus 1. Raise your hand if you had that one right. That's more than half the class. That's awesome. Probably 3/4 of the class. Okay, so that was the key yesterday, was learning how to find an inverse. Now, I want to do one of these domain arranges on the tougher ones with you quick. Go back to the original problem and figure out its domain and range. The domain will be easy. The range, I don't know, some of you might not know. But try the domain at least. So you got x over x plus 3, trying to find the domain and range of that guy. Because then I can reverse them for the domain of the other one. Okay, the domain. I'd just do it with a number line. You can do it with the other way if you want to, with the parentheses and the brackets and the infinities and all that, but I'm just going to do it this way. It just can't be -3. I kind of like number lines, and it's okay with me if you do that. The range is tougher, though. Here's the way you got to think of the range. Do you agree that range goes up and down in a graph? What stops you from going up and down? The asymptotes, horizontal asymptotes. Then I taught you that horizontal asymptotes, which kind of look like this, dotted lines, you know, that go across the horizon. The horizontals are the horizontals. That's the y stuff. And then who can tell you the y asymptotes? Who can tell you y? Bob. And is this one a bob, a bigger on the bottom? No, this one's a same on both. And therefore, if it's the same degree on the top and the bottom, same on both, SOBs are a ratio. And the ratio here is 1 over 1, the ratio of the lead coefficients. So it's y equals 1. So what did I just figure out? I just figured out the one thing that would block it, the asymptote, is at y equals 1. So the range is everything except that one thing that would block it. The range is everything except -1. Now I should really be careful about where I put my -1 and -3 right on top of each other, and that's not smart. It doesn't matter this time, but when you're doing ones where they have to find where they overlap and stuff, then it matters. Okay. This kind I don't care if it's not gonna overlap anyway. It's just used to find your final answer, which is your inverse's domain and range. And the domain comes from the range. So this range here becomes the domain. Everything except -1. And this range comes from the domain. Domain comes down and drops in here. Everything except -3. You don't overlap them or anything. I'm just writing them one above the other. Domain and range of my inverse comes from the domain and range of the original. All right, that's a complete review of yesterday. That's everything I taught yesterday. All right, yes, sir. Because y equals -1 was the one asymptote we knew from. You're right, it's not -1. Okay, everybody pay attention to this. I apologize. I'm going back and I'm going to change this asymptote from -1 to 1 because it was y equals 1 was my ratio. My ratio was this, and for some reason I wrote -1. I cannot explain that. It was +1. Y equals +1. Okay, and the reason it was +1 was because it was a ratio. And the reason we were doing that is because we were trying to figure out the horizontal asymptotes. The horizontal asymptotes are what block the range, and therefore, anyway. Sorry about that. All right, so it's a +1, so this should be a +1 down here, not a -1, so there. Okay. All right. Are there any other questions about yesterday's stuff? So that's, every time we have a day of new stuff, there's probably a test question on that. You get how that works? You probably should kind of notice this pattern. So we've got some kind of a test question or two on this, maybe one easy one on the R2 and then a hard one on the R3. How many are feeling comfortable with the whole inverse thing? Okay, the thing we just talked about there. All right, I know that these can be tough in the algebra, but they're doable. This part where you factor out the y is like a really key moment. All right, here's another day of material. Today's stuff is like this. It's about inverses. Question? I can answer it. No? Okay, good. All right. This new stuff is about inverses, but it's about how to prove two things are inverses. Instead of like saying, would you create the inverse for this one? It'll say, these two might be inverses. Prove if they are or are not inverses. So here's f of x is 3x minus 2. And write this one down. And you definitely want to put a star by this example. It's kind of your go-to example of how to do proving inverses. X plus 2 over 3. This is about proving inverses. And here, do you guys remember when we proved things were odd or even, and you had something like this? You'd have a rule like f of negative x has to equal negative f of x. And then we had a table like this to prove it. Do you remember this? Same thing. You're going to do is a proof table. Okay, except it's not proving odd or even, of course. Here's the thing you have to prove. You have to find f of g of x and see if it's equal to g of f of x. And if they're both equal to x. And you'll find that they are. If they are going to be inverses, they'll both equal x at the end. What that means is, once I stick the one function in the other function and I simplify it down, my answer will come out to x. And if I simplify the other function all the way out, it'll come out to x. Well, we'll find out if they really do. I'll do this problem for you. With you. All right, the g goes into the x. This goes into this. And when I had people come up and ask me questions last hour, the most commonly screwed up thing was just being careful about writing out 3 empty spot minus 2. You do that first. I'm telling you, don't try to do it all in your head. Write out the function with an empty spot, and then drop this in. Okay, x plus 2 over 3. These are not that hard of a question, but you know what I always end up marking wrong is this next step. Because kids will want to go, oh, I can see that multiply by 3 and times or divide 3 will cancel, and plus 2 and minus 2 cancel. So everything cancels, and the answer is x. I can't give you credit for that because math doesn't just go cancel, 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 cancel. You have to do it in the right order. Do you remember that from another kind of problem that we had? Or if you didn't do it in the right order, I couldn't give you the credit. If you like proving the proofs, I had to look and see if you had all your negatives in the right spot to prove that it really didn't work. Well, this is where I'm going to be looking at this part of the problem next. I'm going to be looking for, did the kid know that multiply and divide comes before add and subtract? And that parentheses are the very first thing of all. Is there anything inside this parenthesis that I can do? No. So then I'm done with that. And then I move on to what next? Multiply and divide. And then the last thing I'll do is add, subtract. So all I have to do is do it in the right order. So I multiply, divide part is this part, the 3 and the divide by 3. Do you get that they'll cancel each other? Because times 3 and divide 3 cancel? Or you can think of it as 1 on the top and 1 on the bottom. Once I'm done with that, I have to rewrite the problem to show that that other part, multiplying, is done. Then it's really obvious that the plus 2 and the minus 2 are going to cancel. And your final answer has to be x. Remember, to prove these are really equal, you have to show that they both come out to x. Now I'm going to do the other side, and hopefully when I'm done with it, it'll come out to x. And it will, but I'll just prove it to you. So I'm going to stick the f into the g function. This one is now going into this one. So I'm going to make an empty spot plus 2 over 3. And I'm going to drop in 3x minus 2. Now on this one, kids fresh off that other example usually think, oh, so times 3 and divide 3 cancel. No, wrong. Know why? Because in a giant fraction, do you remember me telling you that you needed to have parentheses around the whole top or the whole bottom, wherever isn't just a single number? If it's just a single number, of course, I don't need parentheses here. But anything other than a single number, you need parentheses there. So if there's parentheses there, do you get that that has to be done first? The whole top of the fraction has to get done first. So that means there is no canceling of the 3 and the divide by 3. I'm only looking in here. What can I do in there? Can the plus 2 and the minus 2 cancel? Yes, they can. So then I'm down to 3x over 3, and now it becomes incredibly obvious that the 3's will cancel. Final answer is x. So why did I do the top first? Because fractions have a parentheses here and here that you may not even see or think about, but they're there, and they make you do the top first. So it's all about the order. Math's very picky. Can't just do it in any order you want. Yes?
So you have to simplify it by the order of operations.
Yes. All right. So the next step is you doing one on your own, but there's one other thing we got to talk about, and that's that whole common denominator thing. So I want to make sure to cover that with you well today. If you want to add these, you can't right now because they don't have a common denominator. But you have to learn how to handle common denominators because this stuff's going to come up. So, everybody try this one. Write this one down. And then put the 5 over 1 because anything that doesn't have a denominator can have a 1 for a denominator. Now, I've told you a couple times ahead of time how to do this. Does anybody remember what I'm going to multiply by? Go ahead. X plus 2 and x plus 2. And can I just do it this way? No, because then I just have a 5x. That'd be wrong. Got to have parentheses. This whole unit is like all about parentheses. Then, you can do this all in one step, and it's totally okay. The bottom is just x plus 2. Do not multiply the bottoms. When you have common denominators, you just leave the bottom the same. Like if I had 1/3 plus 5/3, I would say it's 6/3. I don't add the 3's on the bottom. All right, so the top, you can do that in your head. What's that? 5x plus 10, and then add the 1. What is it? There's your answer. How many had that one right? About half the class. Okay, let's try it again. 1 over x minus 4 plus 3. First step, put it over 1. Second step, multiply by x minus 4. Third step, put it all together. Smart kid in the front row. What'd you get? 3x minus, wasn't it minus 12?
Yeah, but then I have 1.
And then you added the 1. Very good. 12 minus 12 became minus 11. All right, over what? You got it. Raise your hand if you had that one right. Ooh, every kid's the smart kid in the middle of the row. All right. That's common denominators. Now, why do you need that? Because sometimes when you're adding like f plus g, there are going to be ones, and I'll tell you on the test, okay, look, you got to add your common denominators here, but you got to know how to do it. So this is where you'd add two functions, and this would be your combined final function. All right. It's going to come up again in this way. Let's say you had to prove, and I'm doing another one of your homework problems right now. In fact, that makes sense. I should just hand out the homework. I'm going to pause for a second and hand out the homework. All right, so we're going to do number 11 off the worksheet. And would you write underneath the problem that I'm writing out right now, would you please write that rule, f of g of x equals g of f of x equals x? If you didn't take notes on it, I said it really fast there. And the original problem is x plus 1 over x and g of x equals 1 over x minus 1. So I said to write really small, f of g of x equals g of f of x equals x, and then draw a line right down here, all the way to the bottom of the space you have available there. Okay? Now we got to prove that g of f of x equals, f of g of x equals g of f of x. All right. First thing, put the g into the f function. This guy needs to go into here in both places. You know, you can't just put it on the top. So I got to have empty spot plus 1 over empty spot. Then, on the top, we have 1 over x minus 1. And the bottom, I have 1 over x minus 1. That's just me putting the one function into the other function. Now, I don't know if you can tell, but there's going to be a lot of junk to do to simplify this. All right. I know people are tempted to just go, oh, cancel, cancel. And the answer is 1? Nope. Remember what the answer is supposed to come out to be? X. So that's a sign that you're doing it wrong. Besides, do you remember that x plus 1 over x, can you cancel that x or not? That's basically what we have here. And you can't cancel those x's because of why? Because of the addition. Okay? So no, you can't cancel those. All right. That's where a lot of people would have gone wrong. So instead, what we have to do is, look, it's a fraction. What did I tell you about fractions? You have to do the top part like this. You got to do anything in there that you can. So can I add those together? Not yet, because they don't have a common denominator. That's the thing I just taught you 2 seconds ago. So yeah, this is going to take some space. You're going to, I told you to write small. Put it over 1. And put an x minus 1 here. I'm going to clean it up a little bit. And an x minus 1 here. Then I rewrite this puppy. On the top, I'm going to have 1x minus 1 plus 1, which makes an x over x minus 1. All over 1 over x minus 1. Do you get what just happened there? I just did the top. And it came out to that. The bottom's still the same as it was. Now, do you know how to handle a fractional over a fraction? Remember, if it had been like 2/3 over 5/6, you just go multiply by 6/5, right? You flip and multiply. If you do that here, guess what happens? The x minus 1s will end up canceling, and then what will you have left? An x, just like we wanted. So again, I'm going to go x over x minus 1, and I'm going to times, instead of divide, by flip it, x minus 1 over 1, and then this can cancel that. Now, a lot of kids try to buffalo me in their work because they just go like, wave your hands and have a lot of smoke, and then the answer comes out to x at the end. It won't work. I will not give you the credit unless you actually know how the algebra works. Yes, that one does come out to x. I can cancel these guys because it's a multiply and there's one on the top and one on the bottom.
What if you don't do that? You just actually multiply them. Can you still solve it?
If you had actually multiplied it, you would have ended up with x squared minus 1 over x minus 1. And let me just show you, if you hadn't noticed that you could multiply it, or cancel there, you could still save yourself. It would be x squared minus, it'd be x, wouldn't it? Over x minus 1. But then hopefully you'd remember my old advice was that anytime you could factor something, you should. And then hopefully you would have factored out the x right here. X times x minus 1 over x minus 1. And then maybe you would have noticed now you see that the x minus 1s can cancel? Still could have saved yourself if you'd have done the algebra well. Okay. So either way, it ends up coming out to x. Now the other side. Oh, holy crap. Yeah, some of these are that long. If you want the A in this class, you got to be able to handle a problem like that. Or the B. If you can live without an A or a B, you can live with a C. You won't have to handle this problem because it'll be an R3. But that's where I think most of you want the A and the B, so you need to learn how to do this. This is what makes it one of the hardest classes at the high school. Well, it's the most dropped class at the high school. That doesn't make it the hardest class necessarily. Okay?
What about calculus?
I get what you're saying. What the reason some kids say this is harder than calculus is just because you had to kind of like get through this class and then you get to calculus, and it's not like calculus is easy by any means. But you've already kind of gotten used to really hard problems in here, and then all of a sudden calculus doesn't feel like a huge step up. It's just you've moved from, look at all this algebra on the board here. This is one problem, okay? And I even erased some of it, okay? In higher algebra last year, how much would you have had? You'd have never even had one part of this, would you? So this is such a big step up, and then when you go from here, the step from here to calculus isn't so big. I mean, it's a little harder than this, but you've already gotten used to really hard problems if you've made it through this class. Honors Precalc is definitely a hard class, but I don't want to say if it's harder or easier because it's totally different. Honors Precalc is obviously a step up from here. It's honors, but a lot of what the honors part is they're adding in some like writing. Like you got to write a big paper in that class that you don't in here. It's a math paper. And it's got less of the teacher explaining how to do it and more of you have fewer problems to do for homework, but they're all harder. And the teacher isn't explaining them as much. It's more of a, you've got to explore it yourself kind of thing. So there's more of that angle to it. So that does make it harder, but that doesn't mean we're learning like easy stuff in here at all. Okay. So again, when I say it's hardest class, I don't really mean that it's honestly, obviously, Calc 2 is harder than this, but it's such a big step up, and you're not used to these really long, difficult problems. Okay, so let's go to the other side of this thing. I'm going to do it fairly fast, and if you can follow me, cool. At least start the beginning with me. If you've already passed me, go ahead, work on the rest of the worksheet, but I'm going to put the F into the G, so that means this guy needs to go in there. This side's a little easier because there's only one X. So 1 over empty spot minus 1, and I'm going to drop in X plus 1 over X. Then, again, I need to handle this part of the fraction first. So I'm going to fix that by having a common denominator thing. I'm going to put this over 1, and I'm going to multiply it by X on top and X on the bottom. And then I can put it all together and say all of that right there, the X and the negative X, do you see that those guys will cancel each other? And I end up with just 1 over X. And all of a sudden a whole bunch of stuff happens so that now it's really easy. It's just a fraction over a fraction. Common denominators, yep. I know you were thinking of multiplying them. I was thinking about multiplying them too, but you're not multiplying here. You're subtracting. So it's a common denominator thing, so it's just one of them, X. Just like if I had said 1/8, or no, 11/8 minus 5/8, the answer would just have 1/8 on the bottom. The top is where all the action happens. 11 minus 5 is 6. So this top here is where all the action happened. The bottom is just X. Okay, and then from there, hopefully you know that that's 1 over 1, and you flip it and multiply, times by X over 1, and look at that, it came out to X, just like you'd expect it would. I will tell you that usually we give you ones where the answer is that they are inverses, and therefore they're going to come out to X and X. But that's, since kids know that, again, they try to fake the middle part and say the answer is X. I have to read these over really close, and if you don't show me the whole why these guys canceled part, if you don't show me this part right in here and show why it canceled, then I won't give you the credit. Because most people know it's supposed to come out to X. They just don't know how. All right. And that concludes today. You've learned common denominators. I hinted at them before, but now you're officially responsible for knowing them. And you've also learned how to prove two things are inverses. And I'm going to make sure that I do a good review with you on Monday that covers a little bit of everything on the test, and then the test is Tuesday. All right, that's all I got for today.